All right, guys. So we are going to talk about chapter 8-4 and 8-5 together today. They both have to do with rate of change. And so I think it's probably just better just to lump them together rather than stretching it out over 2 days. So in your notes, I do want you to have your 3-ring binders. And in it, we are going to label our notes chapter 8-4 / 8-5, and the name of it is rate of change. Okay, rate of change. And the nice thing about you watching the video is if I'm going too fast or if you're wanting to write some things down and you don't have time, you can always pause the video, get caught up on your notes, and then hit play again and kind of go at your own pace. Okay, so I want you to off to the side of rate of change, I want you to put that is slope. Okay, slope. And I think that most of you have dealt with slope, I believe in your 7th grade year, it was kind of introduced to you. And we are used to hearing slope as rise over run. Okay, and we'll talk about that here in a minute. So there's 2 different kinds of rate of change, and this is why we're combining 8-4 and 8-5 together. Okay, and my pictures are kind of flip-flopped here, but 8-4 deals with more nonlinear, okay, rate of change, and then 8-5 deals with more linear rate of change. And hopefully you can see by having these 2 pictures side by side that this nonlinear example, you can see that from point A to point B, it's kind of at this angle, and then it gets a little bit steeper from point B to point C, and then it flattens out from C to D, and then it actually decreases from D to E down. So you've got an increase, a flat spot where you don't have change, and then you've got a decrease in change. So this is considered non-linear right here, non-linear, and you can see that it does not, if you connect all the segments together, it doesn't create a straight line. Whereas if you look over at the linear example, right, all the way up from point to point, right, from beginning to end, it's just a single straight line. And so the difference between these two is that when you are figuring the rate of change or the slope from point A to point B, it's going to be different than from point B to point C, and from C to D, and from D to E. You're going to have a different rate of change or a different slope value for each one of these little segments. Whereas in the linear one, right, going from this point to this point, it's going to be the same rate of change or the same slope for the entire line. Okay, so it's not really going to be any different. All right, so a couple of things I want you to get used to seeing are some different notations for rise over run. So the long way to write it out here is that, and I'm just going to use slope rather than writing out rate of change, just because I like math, I don't like to write. So if we call it slope, okay, slope is known as the change in y over the change in x. And because mathematicians hate to write, of course, there is a abbreviation for this, and that is the change in y. Okay, that triangle is mathematics way of writing change in. So the change in y over the change in x. And if you think about our coordinate plane, okay, if we have a coordinate plane here, this is your y, and y is up and down. Okay, so your change in y is your change in your up and down movement. And then this is your x-axis, and your x-axis is your change in your left to right or your horizontal movement. So your change in x deals with how far do you move left and right. So if we look at this first example here, if we want to know the rate of change or the slope for this line, we would say that we want to know, and I like to draw a triangle because to me that just makes the most sense. Draw a triangle between your 2 points. Okay, so create a triangle, and I'll show you that it really doesn't matter if you go up and over or if you go down and over, and I'll kind of show you what that looks like here in a second. All right, so my change in Y is my change in direction. Oops, let's keep our color scheme here. Our change in Y is our change right here, this up and down. So from this point to the tip of our triangle, how much do we change, or how much do we, in this case, increase? Well, how many spots do we go up? You got to look at your way your lines are numbered. So we go from 15 up to 30, right? We go from 15 up to 30. So that is a change in, if you think about your change in Y, okay, your change in Y is positive 30. I'm sorry, not 30, 15. We go from 15 to 30, which is a plus 15. And now to do the other half of the fraction, it is the change in X. Well, we want to know the change in X. It's this direction, right? How far do we go from this point, left or right, over to this point to finish off our triangle? And that's going from 1 to 2. So our change in X is a value of 1. And so really you have to watch your numbers along your coordinate plane, because if it's just a generic coordinate plane, right, you might have all of these just be 1, 1, 1, 1, 1, 1, 1, 1, right? If it's some sort of data graph like this, right, each one of these isn't 1, it's 5, 10, 15, 20, 25, 30. So to go from 15 right here up to 30, which is right here, we went from 15 to 30, which is a positive 15 move. All right, so our rate of change for this example here, our rate of change is 15. And you can put 15 over 1, or you can put 15. It doesn't really matter. It's kind of the same. Okay. Now for so for the example here for 8.4, we can't figure out a rate of change for the entire graph all at once, like we could on the linear one, because we have different segments. So if we want to look at just the rate of change, let's use a highlighter here. If we want to look for a rate of change just for this section right here, okay, then that means that we need to see how much do we go up and how much do we go over, right? Rise over run. And you should be used to really hearing this rise over run even more than you are change in Y over change in X. And it means the same thing. It means your Y's, this is your Y axis, and this is your X axis. It's how much do your Y's change, which is your up and down, okay, or your rise. And then your run is your side to side right here. How much do you run? And so for section AB, okay, so if we're just talking about section AB here, our AB slope, well, we rose from 0 to 4, right? This section right here, we rose 4, and we ran from 0 to 4. So we ran 4, so our slope for this section would be 1. Well, now what if we want to look at our slope for the section right here, this BC? It's not a very dark highlighter, is it? Let's make it darker. Here we go. This little section right here, BC. So if we want to know the slope or the rate of change for this section BC, right, then we need to know the rise. So from here to here, what's that rise? Well, that's from 4 to 10. Well, that's a rise of 6. And then if we want to know the run, we go from here to here, which is from 4 to 6, or from 4 to 6, if you can see it down here, right? This little section right here was from 4 to 6, which is a run of 2. And so that would reduce to 3. And so you can see that the section the section AB has a slope of 1. The section BC gets steeper, so it would make sense that it would have a higher slope. So this section right here, this BC, that section has a slope of 3. It's a steeper line than that little section of AB. Well, let's look at the section CD, because this is where it's kind of a special case, and we're going to talk about this probably more so tomorrow, but I still want to just introduce you to it just a bit. So let's look at this section right here. this section CD, okay? Let's make it a little bit darker. There we go. So this section CD. So if I want to find the slope or the rate of change for CD, section CD here, I'm going to go with the rise, or the how far does it take to go from point C to point D? Well, if you notice, there is no rise. If I go from point C right here to point D, I don't rise at all. I'm at 10 and I stay at 10. So from C to D, the rise is 0. I don't rise. Okay. And then if I go the run, which is my left and right, my run is my left and right. It's this direction here. I run from 6 to 10, and that's a run of 4. Well, anything reduced with a 0 on top is just simply 0. So my slope, or my rate of change from C to D, is 0. And then last but not least, let's look at the slope of this D to E. Okay, D to E. We're going to look at that last one. So if we look at the slope of D to E, well, what do we notice about the section D to E that's different? I mentioned earlier, it said it goes down. And so I'll show you what happens with your slope when we go down. So we're still going to create a triangle, but this time our triangle is going to go down and over, right? Because we still want to create a triangle left to right, but it requires us to fall down. So it's rise over run, but rise can actually mean fall as well. So we're going to fall, right, from this point to this point. So we fall from 10 down to 8. So our change in Y, or our fall, is -2. Okay, because we went down. And then our run is still right here. It's from this point right here to this point, right? Here's our run, and that is from 10 to 14. So we run a positive from 10 to 14, that's up 4. And then when we reduce that, we get -2. So notice the difference in our slopes here. We had from AB, we had a slope of 1, and that's right here where we went up by 1 over 1. And then for BC, which was this section right here, we had a slope of 3. It was a steeper slope because it went uphill, more of an incline. And then from C to D right here, we had this 0 slope because it did not increase at all. And then this D to E section, this last section, was actually falling downhill, right? It was running downhill. And so its slope was -2. So anytime you're going uphill or increasing, it's a positive slope. And so you should end up with a positive number. And if you're going downhill, you should end up with a negative number for your slope. Now, I do want to show you one thing, and I'll use this as an example because the graph's a little bit bigger. Remember, I told you it doesn't matter. I use the highlighter here. It doesn't matter if you go up and then over, right? I told you the up and over, that gave you a +15 over a +1 move. But what happens if you make a triangle this way and you go this direction and then you go this direction? Okay, what happens then? Well, I'll tell you what happens. So if you are looking at your fall from this point down here, right? This is your change in Y, right? That's the top number in your fraction. We go down from 30 to 15. So from 30 to 15, that is a change of -15, right? Because we went down 15. Well, now if we run from this point to this point to finish off our triangle, we run backwards. Okay, so we're going backwards here. We go from 2 to 1, which is a -1 move. So our change in Y right here, which this one right here is our change in X. Our change in X is -1. Well, if two negatives cancel out and make a positive, then you still get 15 over 1. And 15 over 1 is what we got when we did it the other way, right? So it doesn't matter if you create your triangle doing a positive and a positive move, right? A positive and a positive is going to give you a positive fraction. Or if you fall first and then run backwards, that's going to be a negative and a negative move, and two negatives still make a positive. So either way, if your line, and we talked about this just a second ago, if your line is running uphill, you should get a positive slope. If your line is running downhill, you should get a negative slope. So this is just kind of a clean version of what we just talked about. Okay. Your rate of change, which can also be denoted as your slope, right? Your rate of change is going to be positive, right? If your line is running uphill or increasing, and it's always reading left to right, just like you would read a word left to right, read your graphs left to right. And if you look at this from the left side to the right side, it's definitely going uphill. If you have a negative slope, well, you're decreasing, which means if you read it left to right, you should be falling downhill, which we are there. And then in this last example, like we already saw in that other example, if you have a zero slope, it means that you're not increasing or decreasing at all. You're just running along at an even line. Okay. All right. So constant rate of change, if you think constant rate of change, I want you to write the word constant rate of change. It's a little bit different than rate of change. And the only way it's different is it's like the 8-5 example. So if you look up here, we had two examples, right? I know it's kind of messy with all the writing that I've done on there already, but let's do this just to clean it up for a second. Okay, all of that now. Now, if you just look at our example for 8-5, which is here, right? It's linear. It's a constant upswing or a constant incline. The example from 8-4, it's jumpy, right? It's here and then it changes and then it changes and then it changes. This one is considered constant. And this one is considered not constant. Okay, so that's the only difference between 8-4 and 8-5 is one, we deal with constant rate of change, and one we look at some graphs with some difference in their rate of change in each section. All right, so your constant rate of change, okay, I want you to put linear because that's what constant means. Constant means linear. And so your constant linear change is your linear slope because we already talked about earlier that rate of change, right? Right here, rate of change means slope. And the word constant, we just said means linear. Okay, so make sure to put that in your notes. So that means that every time, and this is your X's, we've already talked about this, these are X's and these are Y's. Anytime you're looking at a table, okay, if it's running long ways, X's are on top, Y's are on bottom. If it's running this way, X's are always on the left, Y's are always on the right. And if you'll notice, look at the constant change here. If we look at the constant change here, it's +2, it's +2, it's +2, it's +2. To go from 0 to 2 is +2. To go from 0 to or 2 to 4, 4 to 6, and 6 to 8, that's a +2 move every time. If you look at the top row, the change in X, you've got from 0 to 1 is a +1, 1 to 2, 2 to 3, 3 to 4. It's a constant +1, +1, +1. So if we were to write the rate of change for this, remember it's the change in Y over the change in X. So even though Y's are on the bottom of the chart, the change in Y goes on the top of your slope. So it's right here, a +2 change in your Y. And then your change in X is right here, which was a +1. And we know that +2 over +1 reduces to 2. So our rate of change for this example is a 2. Okay, and if you look at what it means data-wise based on this particular graph, it's the Y right here are your number of heartbeats. So it's your change in heartbeats over your X, which is time. So it's over change of time. Okay, so when you have real world data, it means the change in heartbeat over the change in time. Okay, so for every time in seconds, it says, right, time in seconds. So for every 1 second, the heartbeat is expected to beat twice. Okay, all right. This is just an example of what constant versus non-constant might look like. This is a constant positive rate of change. This is a negative constant rate of change or linear rate of change. And because this curves, it's not a straight line, it's considered not a constant rate of change. And the reason is because it is not linear. Okay. All right. Last thing I want to talk about is deciding whether or not you have a proportional relationship that is totally different from whether or not is a constant rate of change or whether it's linear. So it's totally different. And you want to look at your instructions on your homework, and where it says looking if something is proportional, you want to do this little test. Okay. So I'm going to take this first set of X's and Y's, right? And remember, these are Y's and these are X's. Y's are always on the bottom of a graph. And it's easy to get confused because remember, your Y's always go on top and your X's go on bottom. And in a data table, your Y's are on the bottom. So you got to remember to flip them. But you're going to put your Y over your X and create a fraction. So right there, reduce it to 4. Now you're going to do the same thing with the next point. You're going to create a fraction, putting the Y over the X and 8 over 2, and also reduces to 4. And then you're going to do the same thing with the last point. You're going to create a fraction, and then you're going to reduce the fraction. And if these numbers are all the same, then it is considered proportional. Okay, so this particular linear relationship is proportional. And the reason it's proportional is because we did the little proportion test and we got a matching number when we reduced each one of the points separately. Okay, so let's do the same thing here. We've got the first point, which is 4 over 1, because remember your Y's go on top. It's always Y's on top. So it's 4 over 1. Then we do the same thing here, and we do 6 over 2. And then, which that was there. And then we do the same thing again, right? 8 over 3. Now we reduce these. Okay, well, when we reduce these, we get a 4, a 3. Well, you don't even have to keep going. You can stop because those didn't match. These are not equal. And so this is considered non-proportional. Okay, so this is totally separate from the whole constant rate of change linear. This is a kind of separate little subcategory of linear. They're all examples of linear relationships. So if you look at the graph here, this is a straight linear graph, right? If you look at the graph of this one, it is also a straight constant linear graph. Okay, but one is proportional and one is not. And the only way you can tell is to do the little test of setting up each point as a fraction with Y's on top and then reducing and seeing if you get matching numbers or matching proportions. Okay. All right. So I'm just going to really quickly run through a couple of examples here with you. I'm not going to do all of these examples. So for the top of 8-4 on your homework, it'll look like this. It says find the rate of change for the linear function. Something I want to point out, we already know it's going to be linear, which means we're just going to pick 2 points on this graph. I'll pick this point and this point. Doesn't matter. I'm just picking 2 easy points that go right through crossbars so that I can decide what my rate of change is. So remember, your rate of change is in this case, it's a fall because we're going down, and then it's a run. So your up and down, which is your change in Y, right? Your change in Y over your change in X. All right, so let's tally up what those are. So if we look at our change in Y, we go from 30 down to 20. And that is we went down, right? We went down, so it's -10 over. And then if we look at our movement this way, we went from 5 over to 10, which was a +5. And then I reduced that fraction, -10 over 5 is -2. All right, and that should, since it's constant, right? Every time we drop 2, we should go, or I'm sorry, every time we drop 10, which is from 20 to 10, right? We run 5. We drop 10, we run 5. It is a constant rate of change because it is a linear function. And so the slope for this, the slope or the rate of change for this is -2. And if you want to put -2 over 1, you can, because slope is always rise over run, right? And when I say rise, know that I can mean fall if it is a negative. And again, just as a check, my line was running downhill and I got a negative slope. Okay, those match up. You always want to make sure that happens. All right, let's find our rate of change for this table over here. So if I look at, now remember, these are my Y's, right? It says so right here. These are my Y's and these are my X's. So first I want to look at the change in my Y's, right? The change here. Well, it's plus 510. And because it's linear, I know that every one of these is going to be a plus 510 because linear means constant. So plus 510. So my change in Y, and you don't have to write this triangle thing every time. I'm just doing this to show you what kind of my thought process, but my change in Y was plus 510 over, right, over my change in X. Oops, sorry. My change in X. And my change in X, I go from 0 to 5, which is a plus 5 move, and I go a plus 5 move, and from 10 to 15 is a plus 5 move. So my constant rate of change for my X is a plus 5. And then when I reduce that, 510 divided by 5 reduces to 120. So my rate of change, or my slope, for this number 2 example is 120. And if you want to put 120 over 1, you certainly can. Okay. All right. This is an example of a nonlinear. Notice the difference. We've got this slope, and then it gets a little steeper, then it flattens out, then it gets steeper, steeper, a little bit less steep, and then real steep. Okay. So this is not constant. Each section has its own rate of change, and it's going to ask us some questions about the rate of change for certain sections. So number 3 here says, find the approximate rate of change between 1970 and 1975. So we are looking at, here's 1970 and here's 1975. So we are just specifically looking at this section right here. Okay, that's the rate of change. Now it says approximate because these points are not exactly on a cross, like right here are the crosses, and these are the ones that are really easy to know the values for. And this particular point is not exactly on a intersection, so we're just going to approximate it, but we still want to know our change. How much do we go up, right? And it's just a little up, but this one looks to be about 50. That looks to be about 50 because it's 100, 200, 300, so each half mark would be 50. So it looks like we go from about 50 to 100. So our top number, or our rise, was 50. And our run, which is how far over this way do we go? Well, that's easy. We went from 1970 up to 1975. That's a 5-year difference, right? And so our rate of change here is 50 divided by 5, which is 10. Okay, so our rate of change for just that little section is 10. Now it says approximate the rate of change between 2000 and 2005. So now we're over here and we're dealing with 2000 and 2005. So we're dealing with this point and this point. And again, we're going to approximate. So I'm just going to use that 700, and that if you're approximating, that's close enough. So we're going to go our rise, right? This is our point, or this is our line we're looking at. So our segment, I should say, let me do that in black here. That's our segment that we're looking at. And we want to know the rise over the run. The rise was from 700 to 900, and that was a rise of 200. And then we want to know our run. And again, our run was from 2000 to 2005, which was 5. So our run here was 5, was 5. And when we reduce this, we get our rate of change of 40, or 40 over 1. Okay. And then it says, between which 2 years was the rate of change the least? Well, did we have a rate of change that either did not increase at all, or even maybe was a little negative? And that would be right here. So if you look at, let me kind of clear all this off and just look at the graph as a whole right off the bat, you've got kind of a slight slope, a little bit more slope, no slope, and then up, 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 and up. So this section right here between 1980 and 1985, okay, had the rate of change that was the least. And actually this rate of change would be 0 because it didn't increase at all. All right, so that's all I want to do on this section. Let's flip over here to 8-5. It's really much of the same. I'm just going to do one quick example and then be done. So it says, Find the constant rate of change. Well, again, we know that constant, right? Constant rate of change for each linear. We know that constant and linear mean the same thing. So I am going to just pick 2 points. So if I pick the point, right here and right here, okay, I want to know how much do I rise? Now I rose from 0 to 15, right? From 0 to 15. So my top number, my change in y or my rise is 5. And my run, which is how far do I go left or right? I went from 0 to 2. So my run is 2. And because that cannot be reduced, that simply is your answer, 5/2. Okay. I just want to show you if I had picked two different points. So let's just say I picked this point and this point. Well, that's okay. My rise is still this side of my triangle, rising from 30 up to 75, which is a rise of 45. And my run is, how far do I go this way? And that was from 4 to 10, which is a run of 6. And if I reduce both of these numbers, I should get, whoops, sorry. If I reduce 45 and 6, I should get, what did I do here? Oh, I'm sorry, that was supposed to be a 15. Hopefully you caught that. I just wrote it wrong. This right here, sorry. When I did my original slope right here, my rise was from 0 to 15. So this number right here should have been a 15. And for some reason I wrote 5. So 15/2. 15/2 would have been your correct slope. And then on this second one I did where I spread out my points a little bit, I got 45/6. But if I reduce that, I get 15/2. So you'll see that I get the exact same slope. If I do it right, I get the exact same slope no matter what points I pick. You just have to reduce the fraction like I had to here. Okay. All right. The last thing is says determine whether a proportional linear relationship exists between the two quantities. So for exercise 1 right here, we're going to use this one. So that means I'm going to pick a couple of points. So let's pick the point. This point right here is the point 15/2, right? Because you put the y value over the x value. That just stays 15/2. Then you pick the next point. I'll do this one in green right here. This point right here is the point 30/4. So the point 30/4, which reduces to 15/2. And then if I pick, let's pick this point right here. That's the point 60/8, right? Because I'm taking my y value over my x value. So 16, I'm sorry, not 16, 60. 60/8, which reduces to 15/2. So you can see what's happening. Okay, my proportion is always 15/2. So that means that the answer for number 3 is that yes, it's proportional. Now, where it says explain your reasoning, if you show me all of this, that's all I need. Okay, you don't have to write out in words. As long as you show me your work of why you answered yes, then we're good. For exercise or number 4, you use exercise number 2, which is here. And so again, you take your y over your x. So for this first point, it would be 6/1.2. And if I reduce that, my calculator here. And since it's going to be kind of an ugly fraction, we'll just change it into a decimal. 6 divided by 1.2 equals, oh, came out even. It equals 5. Okay. So that's that first one. Now let's look at this one. Let's go to the next point and let's create a proportion out of that y and x. So 8/2.4. Well, if I put in my calculator 8 divided by 2.4, I get 3.333. Well, I can stop. I don't even have to keep going because it doesn't match already. I can answer no, it is not proportional. And again, for explain your reasoning, as long as you show me this, that's all you need to do to explain. All right, so that is it. On your homework on side 1, it's going to be 8-4, which will look very much like this, where you will need to calculate the rate of change. If it's a graph that you're looking at, just simply look at your rise over your run. And remember, rise can also sometimes be a fall if it's going downhill. And or your change in y over your change in x. That's another way to write rise over run. So rise over run, change in y over change in x, both mean the same thing. And then you can calculate rate of change for little sections when you've got a non-linear graph. And then on 8-5, you will have to again calculate rate of change just like earlier. By calculating your rise over your run, right? Or could fall. In this case, it rose, the line went up, and we got a positive slope, which checks out. And then to find whether or not it's proportional, you just take several points from the line, you set them up as ratios or as fractions, you reduce them and you see if they match. If they match, it's yes. If they do not match, then it is no. All right, guys, that's all. You've got a handout for 8-4, 8-5. If you're in class, you'll get a paper copy. If you are at home, you should be able to click load on Cami and do all of your work using the pen tool and the text box tool to show me all of your work. And as always, email me if you have any questions.